Alright, so you know how you guys keep hearing about how James Webb Space Telescope finds all these old galaxies that are too large to be that old? Now, what does that really mean and why is that important? Now, for an example, we found with James Webb Space Telescope a galaxy in 2024, which is one of the oldest dead galaxies. It's named, now let me find the name real quick, Jades GS Z701QU. Sounds like something Elon would name his kid or something like that. But point is, this galaxy stopped forming stars just 700 million years after the Big Bang. Now, that might sound like a long time, but in the universe's timeline, it's barely a toddler. It's about 5% its age. And the galaxy is also really tiny, only about 1,000 light years wide, which compared to the Milky Way's 100,000 is really small. But here's the wild part. The galaxy was already quenched, which means completely dead. Like I said, it stopped forming stars. This makes galaxies redder and older. But that really could shake up what we thought about the early universe, because it suggests that some galaxies can form and burn out fast much quicker than the models that we have can predict. Now, this raises big questions. Why and what shut this galaxy down so early? Was it black holes or gas loss? Now, that's about quenched galaxies. What about galaxies that are just too big? They're not consistent with our models because, like I said, they're too big too early. Growth usually takes time in our lambda CDM model, and it takes time for these small forms of structures and galaxies to merge and create big ones. The early monstrous-sized galaxies should not exist yet. Moreover, these galaxies have a lot of stars already, which means they had an insane amount of star formation in a very short cosmic time frame. Lastly, they're too dense and too evolved. Some even look like mature elliptical galaxies when they should really be just chaotic blobs. The main point is, scientists have to start rethinking our science. Are the galaxies really that big? Maybe we're misinterpreting light that we're receiving from the galaxies. Or is there something missing in our physics, like new dark matter behaviors or early universe conditions that we just didn't know about? But lastly, do we need to update our models? Do we need to update our long-standing tradition of using lambda CDM? Now, it's not the end of the model, but it is something complex about the early universe that we just never thought about before. And JWST is shedding light on this. So we really need to start thinking about what it might mean for physics. If you like this kind of content, hit the follow button and subscribe to the YouTube channel. The link is in the bio. Keep expanding your universe, guys. See you next time.